Alright, so this is a question that somebody gave me and asked for help with. I would describe this as a Physics 1 problem, so circular motion. There's 3 problems. 3 is kind of hard to see, but I'll work it out. We'll start with the first one. So question 1 is saying you have a 2,000 kilogram car that rounds a circular turn of radius 20 meters. If the road is flat and the coefficient of friction between the tires and the road is 0.70, how fast can the car go without skidding? So start by just drawing a little picture. Okay, so we have the circular path, and let's just say the car is going somewhere around the circle, and we know that the radius is r. And if we were to draw a free body diagram for this car, well, we have a normal force acting upwards. We have the force of gravity, or the weight force, acting downwards, and a friction force, which is our centripetal force in this case. So our force, let's just say, in the centripetal direction, is what I usually call it, even though it's not really a direction, is equal to m times your centripetal acceleration. And we know that this is v squared over r. So this is equal to mv squared over r. That's our equation for centripetal acceleration. And the force that's accelerating us towards the center, so if you were going around this turn in a car, you would like lean towards the center. So there's an acceleration towards the center. And the force that's acting in that direction is our friction force. And friction force, the equation for our friction force is mu times the normal. So mu is given. And if we look at the sum of forces, we'll say in the y direction, which we know is equal to 0, right? The car's not bouncing up or down. There's no acceleration in the y direction. We have our normal force minus our weight force, which is mg, equal to 0, which tells us our normal force is equal to mg, which can be substituted into here. And this, like I said, is our centripetal force. So I can plug that in over, set it equal to this. So mu naught times the normal, which is mg, is equal to mv squared over r. Now I think the question wanted speed. So, okay, that masses drop. And you can multiply the r over, and you get mu times g times r. And then if you take the square root, you get mu times g times r square root. And if you plug those into your equation, we're given all of that stuff. So our mu is 0.70. It's kind of hard to see. Ah, here it is. So I'm going to go ahead and plug this in right here. So the square root of mu times the radius, which is 20, times 9.81, which is g. If you plug that in, I get velocity is 11.72 meters per second. Okay. Which, that makes sense if we look at the units. So let's check the units. Mu doesn't have any units. So this is unitless. This is meters per second squared. and this is meters. So our units then is going to be the square root of meters times meters, meters squared per second squared, or meters per second, which checks out. That's our units for velocity. Okay, so that is how we do that problem. Now we'll move on to number 2, which is about an airplane. So in this case, we have an airplane that's going around a circle at a certain speed, and you don't want to exceed 7 Gs. What is the minimum radius of the circular path? So again, I like to draw little pictures here. Maybe we have a plane going around this circle of this unknown radius, but we know that it doesn't want to experience more than 7 Gs of acceleration. And all 7 Gs means is that 7 times 9.81 meters per second squared, which ends up being 68.67 meters per second squared. And this is your centripetal acceleration. Okay, so that's what that's all that the 7G means. Cool, so we know our centripetal acceleration. We want that to be our highest centripetal acceleration. And we know by definition, your centripetal acceleration is v squared over r, which is what it wanted if I, yeah. Yep, v squared over r. Or you can solve for r, and you'll have v squared over our centripetal acceleration. Well, we know what a is now, and we know that this was 100, the velocity. So let's see, that's 100 squared over 7 times 9.81. So I am getting 145.62 meters. And again, we could check the units. So v squared is going to be meters squared per second squared times seconds squared over meters. This drops and we're left with units of meters, which is what we should get. So good. So that tells us the radius that we want. The next one said we want, for part B is asking for the net centripetal force. Well, the centripetal force itself is m times a centripetal. And we just found what a centripetal is from part A, and the mass is given. So all you have to do is take that and multiply by the mass given, which was 80. So when I do that, when I multiply this by the mass, I get 649.92 newtons. And that's part B. Okay. Now we'll move on to question 3, the last question here, which is you have a roller coaster at this point here. It's 500 kilograms, and the vehicle is going 20 meters per second. What is the force of the track on the vehicle at that point, is what it says. So I'm going to draw the picture over here. So it's right here. And if we were to draw a free body diagram, the normal force is going to be upwards. There's going to be a force due to gravity, the weight force. It's kind of an ugly free body diagram. So we have a normal force, and we have a weight force. So if we're set this up right, then the normal force minus the weight force is equal to MA, centripetal. Okay. So at this point, your centripetal acceleration is going to point towards the center. That's what the centripetal acceleration is. It's always center seeking. Now the normal force is just the force from the track onto the cart. So that's from the track onto the cart. And that's what they want. They want the force of the track on the vehicle. So then, the normal force, what we're looking for, is mass times centripetal acceleration plus the weight force. Now we know that this is just plus mg. Okay? So what is the centripetal acceleration? That's essentially all that we need to know here. Well, the centripetal acceleration, we can just use our equation. mv squared over r plus mg. Again, we're just using that the centripetal acceleration is equal to v squared over r. And then from there we know the speed, we know the distance, so we can plug all of this in. So hopefully I can read it okay. 500 times 100 squared over 20 plus 500 times 9.81. Oh, no, I'm looking at the last problem. That's not 100. That would be very, very fast. It's going 20, isn't it? Yeah, so 500 times 20 squared over 10 plus 500 times 9.81. It's really hard for me to see the actual numbers, but I think that's 500, 20 meters per second, and 10. So then you would just plug into here. And then that tells you that your normal force, so 500 times 20 squared over 10 plus 500 times, I'm getting 24,905 newtons. And that's how you do that one. So there was no part B that I could see on there. But this is basically how you would approach these three problems. You're basically using centripetal acceleration and force to work through all these. So hopefully that helps.